Hi there. Welcome, Chem 100 students, to the Chapter 1 lecture. Well, the first half of Chapter 1 lecture. So I always start with the title slide and a chemistry cat meme, and a list of the different sections of the chapter. In this mini recorded lecture, I'm just going through the first half of the chapter, just the topics pertaining to matter, and we'll do measurement in the next class period. So before we get to talking about it, I just want to kind of remind you why it's important to know chemistry. If you're going into a healthcare field, if you're taking anatomy, physiology, the first chapter or section in any anatomy or human biology class is always going to be the chemistry, because chemistry is the foundation of biology, the building blocks of biology. And in order to understand the whole, the body, you need to understand the parts of the body. And the parts go all the way down to the microscopic level. And so while in anatomy you may be thinking of anatomy class as being all about sort of like maybe tissues, organs, and organ systems, yes, that is where they ultimately focus, but diseases a lot of times start or begin at the cellular level or even subcellular level. Toxins, food that we eat, metabolism, all happens at this chemical level. And so in order to be able to understand how cells live, how they get energy, and also how they are damaged in disease, it's really important to understand the chemistry. So that's why we do this. So chemistry is made up of stuff. The stuff of chemistry is called matter. And matter can be classified into different classifications or categories. We have things that are pure substances, so they are all identical particles, if you will, and we have things that are made of mixtures of multiple substances mixed together. So the different types of pure substances are elements and compounds. Elements are the things that are found on your periodic table, all right? There's a limited number of them, and they are ultimately the building blocks of all compounds. Compounds are substances that are made up of atoms of different elements that are bonded together. So water is H2O. That's a classic example of a compound. In a glass of water, it's all H2O molecules, so it's still pure water is a pure substance. Even though it's made up of two different elements, those elements are bonded together, always two hydrogens to one oxygen, so all of the particles are identical, which is different than a mixture. Mixtures are when you have two different substances and they are not bonded together, they're just simply mixed together. All right, so you can have homogeneous mixtures, which are mixtures where you can't tell that it's a mixture because the substances are so well blended that it kind of looks uniform. So a lot of metals are alloys, they are blends. So brass, for example, is a mixture of copper and zinc, two different metals that are blended together sort of seamlessly. So it's a homogeneous mixture. A lot of solutions, so like salt water, sugar water, coffee, juice, are homogeneous mixtures of a bunch of different substances that are all dissolved together in water. Heterogeneous mixtures are ones where you can kind of visually distinguish the different components. Sand is a classic heterogeneous mixture. Maybe from a distance it looks pretty homogeneous, but if you scoop some up and you look at it in your hands, it's lots of different colored, size, shaped particles in it. Salad is another example of a heterogeneous mixture, okay? So being able to identify whether a given substance is an element, a compound, a homogeneous mixture, or a heterogeneous mixture is important. So a little bit more about some of these different types of things. So pure substances are elements. Elements, again, found on the periodic table. Elements can be monoatomic, meaning they just are made of one atom, so like helium. Some elements are diatomic. Hydrogen, oxygen, fluorine, chlorine. These guys like to partner up, to double up. So one molecule of hydrogen is actually two atoms of hydrogen bonded together. It's still a pure substance, and it's still just one element. So it doesn't matter that there's two atoms of it. Ozone is another example. It is three oxygen molecules bonded together, but it's still just purely elemental oxygen. Compounds are atoms of two or more elements that are bonded together. So water, methane is another classic one, CH4, versus our mixtures. So all of these elements can be found on the periodic table. I say the periodic table is your new best friend. You will want to have one printed and keep it close because you will use it often. This is just the one from the inside cover of the textbook, and it's a nice one. The thing I don't like about it is it doesn't have the names of the elements on it. So the one that I provide on Brightspace does actually have the names of the elements. So H is hydrogen, Li is lithium. Things to note about the periodic table. It may seem a little bit busy on this slide, but it is actually a really rich resource. It is a cheat sheet in and of itself. The way the periodic table is arranged, it is arranged in columns and rows. The columns are called groups, and the rows are called periods. So period 1, period 2, period 3, period 4, all right? And the groups, there's two different numbering systems. So the old school, we had the main groups, so those were A, so column 1 and 2, skip over column 3A, 4A, 5A, 6A. That's the numbering system I learned and I still default to, but the newer one is just numbering the columns 1 through 18 straight through. So elements are actually organized in columns based on substances that have similar chemical properties. That's how the periodic table was first built. It seems to like an odd shape. Why is it in this, asymmetric shape? It has to do with things being grouped based on their chemical properties. So everything in a column or a group, also sometimes we call them families, have similar properties. And some of these families have formal names. So group 1 or group 1A is known as the alkali metals. Group 7A or group 17 is known as the halogens. Group 8A or 18 is known as the noble gases. So you should know the different names of these columns that have names. So 1, 2, 17, and 18. All right. The alkali and alkaline earth metals, and so let's see, groups 1 and 2 and 13 through 18 over here. Those are called the main group elements. And this block here, the B columns, are the transition elements. Just more terminology to know. And the color coding here is referring to whether substances are metals or nonmetals. So you can also see a nice organizational setup here. Everything on the left and towards the bottom, these are all metals. Properties of metals, they tend to be solid and shiny and good conductors of electricity. And then on the right side of the periodic table are where the nonmetals live, with the exception of hydrogen. Hydrogen is over here, but really in some ways could be over here. And then you have the staircase right here of elements that kind of sit on the fence between metal and nonmetal. They're metalloid. They have some properties of metals, some properties of nonmetals. So we call them metalloids. So some quick little inquiry activity for you to try, practice using your periodic table. Can you tell me what the chemical symbol for phosphorus is? Using the textbook one would be hard because they don't list the names, but using the Brightspace one, you should be able to find that phosphorus is, the chemical symbol is P for phosphorus. So the letter or two letters, that's the chemical symbol. What group is phosphorus found in? Well, phosphorus is right here, okay? It's in group 5A/15. Either is correct. Is phosphorus a metal or a nonmetal? It is a non-metal. And are most of the elements on the periodic table metals or nonmetals? Well, most of them, according to the periodic table color coding here, are metals. All right. But most, if we were to look at the abundance of all the different elements on planet Earth, Earth's biomass is mostly carbon, the crust is mostly silicon and oxygen. So, in fact, the most abundant elements on Earth are actually the nonmetals. Even though there are a lot of different metals, they're lower in abundance. So when it comes to chemistry, we have to, write chemical formulas and chemical equations. So just a brief intro into what a chemical formula looks like. It is the chemical symbol of the different elements that are in that molecule, and then we use subscripts to indicate how many atoms there are. So, for example, this would be called sodium sulfate. It means it has Na is the chemical symbol for sodium, so it means there's 2 atoms of sodium, there's 1 atom of sulfur, and there's 4 atoms of oxygen, all bonded together in a single molecule. Okay, so those are our pure substances, everything about elements and compounds. Now, let's go back to those mixtures. Mixtures can be either homogeneous or heterogeneous. Remember, homogeneous means the composition is uniform throughout, so it's evenly mixed. It kind of all looks uniform. So milk, basically any beverage, except maybe a smoothie that's not well blended, it's a little chunky, would be more of a heterogeneous mixture. Juices would be homogeneous. I like the milk example because when you buy milk, it often says homogenized. So if you have a cow and you milk a cow and you get fresh milk, the milk will actually separate out into layers, the fat layer and the water layer. But by vigorously mixing it, you can actually get the fat particles to break up and suspend themselves. So that's what homogenized milk is. Skim milk is made by simply skimming off that fat layer, getting rid of the fat, and just drinking the water layer. So fun facts for you. Most metals that we use are blends of different metals. And heterogeneous mixtures are usually you can distinguish the different components. They're visually distinguishable or they're easily separated. In none of these situations are the atoms bonded together the way they are in compounds. They're just mixed together. That's the difference between a mixture and a compound. So it's common in chemistry textbooks to view things or to represent substances, elements, compounds as particles, like little balls in boxes. And so this is just kind of showing you the differences between, the subtle differences between these different kind of terms. So elements are made up of individual atoms. There are some elements that are made of molecules, where it's still just this all identical atoms, but those atoms happen to be bonded together or connected together. So you can see that these are both examples of elements. They're both pure substances because all of the particles in the boxes are identical to one another. And so those would be an example of a pure substance, different types of elements. Mixtures, there's a variety of different types of mixtures. You could have mixtures of atoms. So these would be single atoms of the green element and single atoms of the orange element that are mixed together. Notice they are separated. The balls are set, they're not stuck together. So that's how they are a mixture versus a compound. In a compound, we have green elements and pink elements, but those atoms are bonded together. They're stuck together. And all of these particles, these little Mickey Mouse looking particles, are all identical. So compounds are still a pure substance because all the particles are identical. Mixtures are mixtures because all the particles here are not identical. There's at least 2 different types of particles in each of these containers, if you will. So just I like this visual to distinguish these different definitions. So vocabulary is really an important part of learning any new subject, including sciences, especially chemistry. So making sure that you understand the definition of each of these different terms, the definition of an atom versus a molecule versus an element versus a compound versus a mixture. Knowing those definitions sort of verbally, but also being able to identify or distinguish them visually in this particle model. So a little quick practice question for you here. Would you classify the following matter as an element, a compound, or a mixture? And if you classify it as a mixture, indicate whether it's homogeneous or heterogeneous. And I forgot to mention a little etymology here. Homogeneous, homo means same. That is a prefix in Latin that means same, so it means it's the same throughout. And hetero means different. So heterogeneous are different things. You can differentiate the components. All right, so pause the video, try this, answer this on yourself. The answers here are table salt, and I give it away with the chemical formula here. It's sodium chloride, NaCl, is two elements bonded together. Therefore, table salt is a compound. Nickel, the chemical symbol for nickel is Ni, and a single chemical symbol means it's a single element from the periodic table, hence it is an element. Vegetable soup, it is a soup containing lots of different vegetables, usually chunked. I suppose there might be some people who make vegetable soup by blending it all in a blender, and then that would be different. Like maybe like tomato soup is more homogeneous, like a typical like tomato soup. But vegetable soup is usually chunky, so I would say it is a heterogeneous mixture. And air, you might think air is pure, a pure substance, but it is not. Air is actually a mixture of gases containing carbon dioxide, oxygen, nitrogen, hydrogen. There's lots of different gases in the air that we breathe. It's not all pure oxygen. So it is a mixture, but it is very homogeneous, a homogeneous mixture. And then the last thing I just want to go over is the different states of matter. So I have animation on this slide. How to make it? There we go. So matter, atoms, elements, compounds, mixtures, whatever, they can exist in different states, either solid, liquid, or gas. And the difference between these states, both characteristically and from a particle view, all right, solids are made up of particles, atoms, compounds, that are tightly packed together in rigid structures. The particles are moving, all right, but it's more like they're vibrating. And wiggling a little bit, but they can't really move around, which is why solid substances have a fixed shape. They also have a fixed volume, like my mug here or my headphones. Okay, they have a fixed shape. I can't compress it. I can't make it squish. Liquids are molecules or particles or atoms that are moving around freely. They can kind of roll around each other, but they're still very close. They're all still touching each other. And so because of that, they have a flexible shape. They can flow. If you take liquid from a small cup and you pour it into a big cup, it's still the same volume, but it'll take on a different shape. You can pour water into various containers. It'll always take the shape of its container, but 1 cup of water will always just be 1 cup of water. So it has definite volume, but flexible shape. Gases are the most flexible state of matter. In gases, the particles are moving around very, very fast and bumping off of each other, not sticking to each other like they are in liquids and solids. And so because of that, gases can expand to fill whatever volume of space they are in. They can take the shape of any container that they're in. They can be compressed into a smaller volume. So they have both a flexible shape and a flexible volume. And as we'll see is the lecture continues, that in order to go from one state to another, we add energy. So if you heat up a solid, you can melt it into a liquid. Liquids can be heated into gases, and then conversely, if we cool gases, we can cool them or condense them into liquids or freeze them into solids. So that is the basics of matter. Do a little bit of homework to quiz yourself on these topics and study the vocabulary, and I will see you in our next live class. Thanks for watching.